Somewhere above you, beyond the moon, beyond Mars, beyond the bright, easy map of the planets, something older than most web pages, older than home computers, older than many living engineers, is still listening. It does not glow for us, it does not turn and wave. It only keeps a narrow, metal face pointed back at Earth, and answers in a signal so faint that NASA needs one special dish just to speak loudly enough to reach it. That is part of what makes this story feel almost unfair. Voyager 1 survived the violence of launch in 1977, raced past Jupiter in 1979, crossed Saturn in 1980, and entered interstellar space in August 2012. It has already done enough for 3 lifetimes of machines. And yet now, after all of that distance and all of that time, the danger is not some giant collision or sudden cosmic storm. It is a closing window, a tired set of thrusters, and a silence that could arrive simply because Earth has to look away for a while. If you listen closely, that changes the mood. This is not the usual story of a spacecraft dying alone in the dark. This is a story about timing, about a tiny delay becoming a crisis, about a machine more than 15 billion miles away, depending on a narrow strip of calendar space down here on Earth, while engineers race a clock that does not care how legendary the mission already is. To see why this matters, we need to step back. Most people believe Voyager 1 has already beaten the hard part, and that from here on out it is simply drifting bravely until the power runs low and the mission fades in a straight line. If the signal still comes home, then the story feels stable. If the power lasts, the mission lasts. That assumption sounds so reasonable that it is easy to miss the trap hidden inside it. Voyager 1 has always lived in the shadow of its own fame. People know the name. They know the golden record. They know the pale blue dot story that Carl Sagan helped make immortal. But many people hold the mission in their minds like an old photograph, finished long ago, a symbol more than a working machine. That is part of why its present tense is so easy to overlook. In truth, Voyager 1 is not a museum piece. NASA still tracks it. The Deep Space Network still points giant antennas at it. Engineers still send commands and wait nearly a full day for those commands to arrive. Then they wait nearly another day to learn whether the spacecraft understood. The conversation is painfully slow, but it is still a conversation. The spacecraft itself is not large. Voyager 1 launched on September 5, 1977, with a mass of about 1,592 pounds, according to NASA's mission page. It rode a Titan IIIe Centaur rocket out of Cape Canaveral. It was sent on a faster route than Voyager 2, even though Voyager 2 launched earlier. By December 15, 1977, it had already overtaken its twin. Its early life was full of spectacle. At Jupiter, NASA says Voyager 1 discovered a thin ring and 2 new moons, Thebe and Metis. At Saturn, it found 5 new moons and the G-ring. It showed us storms, ice, haze, and strange light in places that had been little more than blurry points before then. For a while, the mission looked like a grand tour of giant planets. Then it became something even rarer. After Saturn, Voyager 1 did not head toward Uranus or Neptune. Its path bent north, out of the flat planetary plane. That was partly because of the mission's Titan flyby. It traded one future for another. Instead of touring every giant world, it went chasing a harder edge, the place where the sun's power thins out and interstellar space begins. That choice still shapes what matters today. NASA's Voyager interstellar mission page describes the next steps in plain terms. The goal was to study the outer solar system, find the heliopause, and then study interstellar space itself. The heliopause is the border where the sun's long bubble of particles and magnetic force gives way to the wider gas between stars. Voyager 1 crossed into interstellar space on August 25, 2012, at about 122 astronomical units from the sun. No human-made object had ever done that before. That crossing was not obvious at first. One key instrument, the plasma science instrument, had stopped working years earlier. So when particle readings changed in 2012, the science team could not instantly declare victory. Only later, when the plasma wave system detected oscillations that showed denser plasma around the craft, did the picture sharpen. Even the greatest threshold in the mission arrived not with fireworks, but with patient argument, delayed proof, and careful listening. That pattern matters. Voyager 1 has never been a machine that gives easy drama on schedule. Its stories unfold in slow motion. A number shifts, a signal weakens, an instrument goes quiet, a reading comes back stranger than expected. Then, months or years later, the meaning clicks into place. If you want to understand why NASA's closing window matters now, you have to accept that almost everything about Voyager 1 happens late, faintly, and after long doubt. From far away, that can make the mission seem oddly safe. It already survived launch. It already survived planetary flybys. It already survived the cold far beyond the outer planets. By 2025, it had been operating for nearly half a century. As Suzanne Dodd of NASA's Jet Propulsion Laboratory put it in 2025, the Voyagers had been deep space rock stars since launch. Patrick Cohn, NASA's Voyager program scientist, said each extra bit of data was bonus science and a testament to the engineering. And that is exactly how the mission can fool you. Because when a spacecraft keeps answering year after year, the mind starts smoothing out the danger. You picture a dependable relay in deep space. You imagine that the real enemy is just electricity. NASA says the spacecraft loses about 4 watts of power each year from its radioisotope power system, which turns heat from decaying plutonium into electricity. So the story seems simple. Power down instruments, stretch the mission, and ride the signal as long as it lasts. There is some truth in that picture. Engineers have been shutting off instruments step by step to buy time. NASA turned off Voyager 1's cosmic ray subsystem on February 25, 2025. Voyager 1's low-energy charged particle instrument kept running through the rest of 2025, but NASA planned to shut that down later. By April 17, 2026, engineers did shut it off. That left Voyager 1 with 2 science instruments still operating, the magnetometer and the plasma wave subsystem. Every cut was a hard choice, but it looked like a controlled retreat, and because those choices were planned, they seemed almost calm. NASA had already worked out the order years in advance. The mission was not improvising from scratch, it was subtracting, carefully. One instrument off, a heater off, another system cooled but not frozen. The image this creates is a slow, tidy dimming, like turning lights off room by room in a house before bed. Nothing in that picture suggests a closing emergency window. Even distance can sound routine once repeated enough times. In 2025, NASA described Voyager 1 as more than 15 billion miles away. Signals from Earth took over 23 hours to reach it. That already sounds unreal, but the mission had lived with such delays for years. By 2026, NASA said Voyager 1 was approaching 1 light day from Earth. A command sent from Earth would need a full day to get there. That is astonishing, but still it can seem like just another milestone on a stable road. So the assumption settles in. Voyager 1 is old, but steady, fragile, but predictable, remote, but reachable. As long as the power lasts and the antenna stays pointed home, we can keep talking. And if the end comes, it will come because the spacecraft finally runs out of energy, not because anything dramatic changes all at once. That is the comfortable version of the story. It is also the version that hides the real danger. But that picture is about to change. What we have just taken for granted turns out to be a small part of a much larger story, and the part most people miss is not out near Voyager at all. It begins back on Earth, with one giant antenna, one repair schedule, and one set of thrusters NASA thought had died back in 2004. Write the moment your own assumption cracked in the comments. That helps us see which blind spot should shape the next deep dive on this channel. Because the truth of this story is not that Voyager is simply fading. The truth is that contact itself had to be rescued before a closing door swung shut. The rescue starts with a piece of the spacecraft most people never think about. Voyager 1 has to keep its high-gain antenna pointed at Earth with exquisite accuracy. That means it must make tiny orientation changes, small turns, small corrections, little nudges that never show up in paintings of the mission. The spacecraft uses thrusters for this. Not the dramatic sort that change worlds, but the careful kind that keep a whisper aimed through dark. Among those are roll thrusters. Think of roll as the motion you would make if you spun a bottle in your hand. NASA says Voyager uses that motion to keep itself lined up with a guide star. Seen from Earth, the antenna rotates like a vinyl record. If the roll control goes bad, the spacecraft can lose its precise aim. If it loses its aim, the conversation ends, even if the spacecraft itself is still alive. For years, Voyager 1 seemed to have that problem under control. The primary roll thrusters had stopped working in 2004 after the small internal heaters lost power. Engineers at the time judged the heaters likely unfixable, so the mission switched to the backup roll thrusters. That seemed fine. As Kareem Badarudin, Voyager mission manager at JPL, said in 2025, the The team likely did not think the Voyagers would still be going another 20 years. Why worry about a dead backup to the backup if the mission was already living on borrowed time? Then time kept passing. The backup roll thrusters, the ones doing the real work since 2004, began facing their own threat. NASA said fuel tubes in the active thrusters were building up residue. That residue could clog the lines badly enough to stop the thrusters as early as the fall of 2025. So now the mission was staring at a bad possibility. The working thrusters might fail. The primary roll thrusters had been considered dead for 21 years, and without roll control, a whole chain of trouble could begin. If that were the only problem, engineers could still plan slowly. They could study options. They could test ideas. They could send new commands whenever needed. But that is when Earth entered the story. NASA announced that Deep Space Station 43, called DSS-43, a 70-meter dish in Canberra, Australia, would be offline for major upgrades from May 4, 2025 through February 2026, with only brief returns in August and December. And NASA said something even more important than that. DSS-43 was the only dish with enough signal power to send commands to the Voyagers. That changes the shape of the whole problem. Suddenly the mission was not just dealing with a distant spacecraft, it was dealing with a deadline. If the backup roll thrusters clogged after DSS-43 went offline, NASA might not be able to send the kind of commands needed to save the situation until months later. The closing window in the title is not poetic, it was literal. A period when Earth could still shout loudly enough at Voyager 1 was about to shrink almost shut. What was expected was grim but simple. The dead primary roll thrusters would stay dead. The backup roll thrusters would keep working for as long as they could. NASA would hope the residue built up slowly enough to buy time. What engineers actually found was a slim, dangerous chance that the old diagnosis from 2004 might not be the full story. And the surprise felt like finding a locked door in your house that turns out not to be locked at all, if only you dare twist the handle one more time. The clue came from re-examining the old failure. Engineers began to suspect that an unexpected change in the heater power circuit may have flipped a switch into the wrong position. If that was true, the heaters were not dead in the way everyone had assumed. They were unavailable. That is a huge difference when your spacecraft is more than 15 billion miles away. Dead means mourn it. Unavailable means maybe, just maybe, you can still call it back. But the attempt itself was risky. NASA explained that the team would have to turn on the dormant roll thrusters, then try fixing and restarting the heaters. If the star tracker drifted too far from its guide star during that process, the thrusters could fire automatically because of the spacecraft's programming. If they fired while still too cold, NASA feared a small explosion. So the team had to point the star tracker as precisely as possible and then move through the commands like a bomb squad working at the end of a long hallway. There is another layer of stress here that only space missions can create. A command to Voyager 1 does not produce immediate suspense. It produces delayed suspense. By the time engineers receive a reply, the crucial event happened almost a full day earlier. You do not watch the moment as it occurs, you watch the past arrive. That means when the team tried its fix in March 2025, they were not reacting live. They were waiting for history to roll toward them at the speed of light. NASA says the critical test played out on March 20th. The team had done the work ahead of the May deadline. They waited. Then, about 23 hours after the radio signal had crossed the Gulf, and roughly another day before the return was seen on Earth, the answer appeared. Within 20 minutes of the telemetry coming back, engineers saw the heater temperatures rise sharply. The old thrusters were alive. Not new, not perfect, but alive enough to matter. Todd Barber, the mission's propulsion lead at JPL, called it yet another miracle save for Voyager. And that phrase is worth sitting with for a second. Miracle save, not routine maintenance, not a small adjustment, a save. The mission had reached a point where success depended on waking up hardware that had been written off 2 decades earlier, under a deadline imposed by a single antenna on another continent. That is not the story most people think they know. What was expected next was a quiet continuation. If the thrusters worked, perhaps the rest would be easy. What actually followed was a reminder that Voyager 1 never stays simple for long. The spacecraft was already moving through a separate season of fragility. In 2024, NASA had dealt with a different problem, a fault in the flight data subsystem that prevented usable engineering information from coming home. The team had to split code into sections and move it to different places in memory. When the fix worked in April 2024, it ended 5 months of uncertainty. That matters because it shows the real state of the mission. Voyager 1 is not one problem away from peace. It is an old explorer held together by deep knowledge, patience, and courage to try weird ideas that should have expired many presidents ago. In May 2022, JPL had already described another mystery involving invalid data from the Attitude Articulation and Control System, or AACS, even while the spacecraft seemed to be operating normally. That is life at the edge of human engineering. Things break in ways that do not fit neat boxes. And yet, through all of this, the spacecraft keeps giving. The reason NASA fights this hard is not nostalgia. It is science. Voyager 1 and Voyager 2 are the only spacecraft operating outside the heliosphere. NASA says the current mission is measuring interstellar magnetic fields, particles, and plasma waves. That sounds abstract until you slow it down. This is our only direct instrument inside the stuff between stars. It is like having one thermometer hanging outside the walls of the house while everyone else is still indoors guessing the weather. The surprises from that region do not arrive as pretty pictures. Voyager's cameras were turned off decades ago to save power. No more blue crescents, no more family portraits. The science now is made of particles, fields, densities, and waves. What scientists expected back in the old planetary era was that the mission's great visual drama was already over. What they actually found is that the quiet data beyond the planets can force whole new ideas about where the sun ends and the galaxy begins. The surprise feels like opening an old mailbox and finding tomorrow's weather inside. NASA's Interstellar Mission page gives one strong example. When Voyager 1 crossed the heliopause in 2012, the team did not immediately know it with certainty. The particle data hinted at it, but because the plasma science instrument had failed long before, the crossing could not be confirmed the easy way. Only later, when the plasma wave subsystem detected oscillations that meant denser plasma surrounded the craft, did the evidence lock together. What was expected was a clean line. What was found was a threshold that had to be heard before it could be trusted. That kind of slow truth changes how you see the 2025 thruster story. This was not only a battle to keep a famous craft alive, it was a battle to keep open the only moving instrument package we have in an environment no other human machine occupies. Linda Spilker, Voyager project scientist at JPL, said in 2025 that every day could be the spacecraft's last, but that day could also bring another interstellar revelation. That is the trade. Every extra week is both risk and discovery. Soon after the March 2025 thruster revival, another hard decision arrived. On February 25, 2025, NASA shut off Voyager 1's cosmic ray subsystem to save power. That instrument had helped determine when and where Voyager 1 exited the heliosphere. Turning it off was not like removing a dead bulb. It was like closing the eye of a witness that had been on duty since the Carter administration. Still, engineers judged the trade worth it because keeping the spacecraft alive longer could preserve other unique measurements. By then, the mission had become a lesson in subtraction. On Voyager 2, NASA shut off the low-energy charged particle instrument on March 24, 2025. On Voyager 1, the low-energy charged particle instrument stayed on through the rest of 2025. Then, on April 17, 2026, JPL sent commands to turn that off too. Kareem Badarudin said shutting down a science instrument was not anyone's preference, but it was the best option available. This is how long missions survive, not by avoiding loss, but by choosing which loss buys the most future. There is a painful beauty in that method. A household does this in winter when the power bill climbs. You shut one room, you wear another layer, you decide what truly must stay warm. Voyager 1 is doing the same thing 25 billion kilometers away. NASA even said engineers must make sure the spacecraft does not get so cold that its fuel lines freeze. That detail snaps the story into focus. The farthest craft ever built is living, in part, like an old house in a hard season. Roughly two-thirds of the way through this story, it is worth admitting something the mission itself has always taught. Not everything is neat, and not everything is fully settled. Even the 2012 crossing into interstellar space was not immediately clear. Even now, the spacecraft is sending data from a place with no nearby partner craft, no camera view, and no fast second opinion. The people studying Voyager know more than anyone else on Earth about this region. They also know how much they still cannot check twice. That uncertainty is not weakness. It is why the mission matters. Clean answers are easy to celebrate, but rough edges are where discovery lives. Voyager does not just send results, It sends pressure against our assumptions. A strange plasma reading, a magnetic clue, a signal delay that grows so long it changes how engineers think. Each one says the universe is not arranged for our convenience. We have to learn it the slow way. And the slow way was getting slower. NASA's Where Are Voyager 1 and Voyager 2 Now page says Voyager 1 is on track to reach one light day from Earth on November 18, 2026 at 2:16:07 a.m. Pacific Standard Time. That means 24 hours for light itself to cross the gap. A spacecraft that once raced between giant planets now lives in a place where every conversation spans two sunrises. What was expected in old space-age dreams was dramatic closeness. What was found instead is a kind of intimacy stretched across a full day of waiting. Meanwhile, the Earth side of the system remained just as important as the spacecraft side. DSS-43 in Canberra was going offline for upgrades because NASA needs stronger deep space communication for future missions, including crewed lunar work. Suzanne Dodd said those upgrades also increase capacity for science missions that build on Voyager's discoveries. That means the closing window was not caused by neglect, it was caused by growth. The future of exploration was briefly pulling attention away from the oldest explorer still speaking. That is where this becomes more than a clever engineering story. A civilization has only so many giant ears, only so many experts who still understand the habits of a machine built in the 1970s, only so much power left inside the craft, only so many ways to keep propellant flowing through lines touched by time. Voyager 1 is not just running out of electricity. It is running through a narrowing corridor where timing, hardware, and human skill must keep overlapping just long enough. By April 2026, NASA said shutting down the low-energy charged particles experiment would give Voyager 1 about a year of breathing room. At the same time, engineers were preparing a more ambitious power-saving fix, nicknamed the Big Bang. The plan was to switch out a group of powered devices all at once, turning some things off and replacing them with lower power alternatives while keeping the spacecraft warm enough to go on doing science. NASA planned to test that on Voyager 2 in May and June 2026, then try Voyager 1 no sooner than July if the test worked. Even in that technical phrase, you can hear the mood of the mission. Breathing room, not security, not certainty, just room to breathe. And that is the reveal at the center of this whole story. Voyager 1 is not merely drifting until its battery fades. It is crossing a zone where every contact depends on a shrinking set of conditions still lining up. The spacecraft is alive. The science is alive. But the open window that lets Earth still reach it is becoming rarer, narrower, and harder won. And here is where this stops being about one machine and begins being about us. If the reveal in this story is right, then space exploration is not only about launching bold new hardware, it is also about how patiently a society protects the thin threads connecting it to old discovery. A mission can be half a century old and still tell the future something new. Send this video to the one person in your life who still thinks old missions only make old news. That single share can pull one more mind into the strange truth that our farthest science depends on choices being made right now. Because the wider question is no longer whether Voyager 1 was important. It is whether we know how to stay faithful to knowledge once the applause is gone. What changes now is the way we should look at every update from Voyager 1. A shutdown is no longer just a shutdown. A power-saving move is no longer just a technical note. Each one is part of a bargain. Turn one instrument off so another can speak longer. Wake a dead thruster so a narrow antenna beam can stay homeward. Upgrade an Earth dish so future missions can grow, but accept that the old mission must squeeze through brief openings while the work happens. Nothing about this is passive. It also changes what mission success means. Voyager 1 already succeeded many times over. Its original job was Jupiter and Saturn. Everything after that became extension, then legacy, then miracle. Now success is measured in extra days of signal, in clean packets of data from 2 remaining instruments, and in careful choices that may carry useful science into the 2030s. NASA said in 2025 that engineers believed the probes could continue operating with at least one science instrument into the 2030s, though unforeseen problems could shorten that timeline. That is not a promise. It is a hard-earned possibility. For the viewer at home, there is a simple anchor for all of this. Imagine sending a text today and getting the reply tomorrow. Now imagine that one text is not gossip or dinner plans. It is a life-supporting instruction for a machine no human can touch. That is Voyager 1 now. When engineers decide to try a fix, they do not lean over a bench and adjust a screw. They commit a thought to radio, wait almost a day for it to arrive, then wait again to see whether the dark said yes. The science that remains is still precious. As of April 17, 2026, NASA said Voyager 1 still had the magnetometer and plasma wave subsystem operating. Those tools continue to measure magnetic fields and listen to plasma waves in interstellar space. No other craft is out there beside it taking the same notes. That means even stripped-down Voyager is not empty. It is focused. Like an elderly witness who has lost some senses but still hears the one sound no one else in the room can catch. The future planning around the spacecraft is now sharply dated. NASA's April 17, 2026 update said the Big Bang power-saving approach would be tested on Voyager 2 in May and June 2026. If that worked, Voyager 1 could receive the same treatment no sooner than July 2026. NASA even said there was a chance, if the fix worked well enough, that Voyager 1's low-energy charged particles experiment could someday be switched back on. That one detail matters because it shows the mission is not only shedding capability, it is still searching for small reversals. So when the next Voyager update appears, the right feeling is not pity, it is attention. This is what the late phase of a civilization-scale instrument sounds like. A little weaker, a little slower, still astonishingly alive. And because the spacecraft is now so far away, each saved month is not just more time on a mission clock. It is more distance placed between humanity and the sun, while the line of communication still holds. What comes next will not be loud. There may be no triumphant image, no parade, no clean, final speech. There will be a line in a NASA update, a note about a successful power change, a mention of an instrument still on, a quiet acknowledgement that one more command got through. Then, somewhere farther ahead, there will be a last useful science return. Maybe after that, a last engineering signal. Maybe later still, silence. But that silence is not here yet, and until it arrives, every working contact with Voyager 1 is a live bridge to a place nothing else we have made has reached. Save the November 18, 2026 milestone somewhere private. That date gives you a personal marker for when the farthest human-made object reaches one light day from home, and keeping it lets you feel the scale in your own life. Because tomorrow, and the day after that, someone will still be trying to hold a conversation across that full day of light. And if they succeed, the future will not feel abstract at all. It will feel like a reply finally coming back. There is something beautiful about the horizon directly ahead of this mission. Not beautiful because it is safe. Not beautiful because it is guaranteed. Beautiful because it is still open. NASA's own updates make that plain. In 2026, the team was still planning new power-saving strategies. The magnetometer and plasma wave instrument were still returning data. The giant dish in Canberra still mattered. The spacecraft was still close enough, in the strange language of deep space, to answer. Soon, Voyager 1 will be farther than any signal delay most of us can emotionally picture. One light day is not just a measurement. It is a new kind of loneliness in numbers. And still the spacecraft will go on moving. Still the sun will shrink behind it. Still the interstellar medium will press around it. Still, for as long as the hardware and the timing allow, that narrow antenna will keep trying to face the world that made it. When that date arrives, think about the shape of the moment. No flash in the sky, no sound you can hear from your porch. Just a spacecraft 169,479,096 miles away, a command taking 24 hours to reach it, and a species on one small planet still caring enough to send that command anyway. That image holds almost everything. Distance without abandonment, age without irrelevance, silence without surrender. And that is why this closing window matters so much. Not because Voyager 1 is dying today, but because the chance to keep reaching it has become precious in a way most missions never have to face. Some windows reopen. This one, in the form it once existed, will not. The easy years are gone. The roomy margins are gone. What remains is the narrow art of staying in contact a little longer than anyone expected. If the mission keeps speaking into 2027 and beyond, it will do so because many small things kept working together at once. A heater, a thruster, a radio dish, a line of code moved in memory, a power plan judged correctly, a team patient enough to wait 2 days for every real answer. That is not a romantic idea of the future. It is the real one. And it may be the warmest, strongest proof we have that the future still belongs to those who keep listening.